What's back? Okay, what's back? That's a mathematics concept. What's a set? You learn computer science or you learn any math, you know what it means a set. A set is made by the element of the set, right? The element of the set never repeat. You have A, B, C, D, and all the way to Z. That's the set of the alpha beta. But if you have A, D, E, C, that's not a set. You repeat the A, that's a back. And basically, the backing comes from the sampling strategy. We sampling with placement. We just, you get 10. I'm going to pick 10, pick one, put it in the bag, and put it back. I select another one, and in that way, you can have one example repeated a couple times. Just happen to pick it again, right? Just like your telephone number. You call, you don't have to always call different number. You can call 7741, like my phone number. You can have 2 sevens. So the idea is pretty simple. Randomer create samples. This is the key. It's what's called the bagging with replacement. You want to put it back. And then you form a data set for the training and also for testing. And then you create the classify. For each sample, you could get the model could be the same, like a decision tree. The decision tree are sometimes very sensitive, especially when your data set is very small. 1 or 2 change will make the tree construct completely different. So that is unstable, unstable. If it's unstable, you can take advantage of the majority. And then after you run all this classify, and then you let the majority vote. And then who is the vote? The majority vote is the class you're going to be predicted. And then you go to the testing. Give an example. The J48. If you use the default setting of Weka, that's what they do. The example given by the book is all small in order to help you understand. How many? 14, let's say. The whole set of training and the testing data is only 14 examples. What you're going to do in beginning is each time, let's say, I want to select the 14 for the training set. But I'm going to put it back, pick it and put it back, and pick it, put it back with 14. You bet each time you are not going to get the same thing because you put it back, right? You can get A this time, and then 1 could not get it. And the next time you could get C 3 times, and then some miss. You can do this for 10 rounds. Each time to do this, that's called cross-validation. When you finish 10 times or 14 times, it's up to you 15 times. And then you're going to see if you give it an instance, you build 14 classified or 10 classified. You input to the 14 of the classified, let the 14 to vote which one should win. And that's how you are going to do that. We call it the bagging. Classified. Make sense? You just this is better.
So if it was even, it would be like a normal distribution, right? Each bag would have.
The sampling, you're talking about sampling?
Yes.
Random pick. You just pick one and put it back, pick one, put it back, pick one. The chance to be 2 bags are exactly the same is very small. From statistics, it's almost 0. We can do a little calculation. No, like this. We have 10 elements from 1 to 10. The first one that you pick the 10 3 times. Can you see it? And the second bag you put this 3 times. The third bag you pick the 5 3 times. That's all random. What is the possibility each element, if you pick a 10 out of 10, when you put it back, it's very simple. Let's assume each element have 1/10 opportunity to be picked up. And then the possibility be picked up is 1/n, then not picked in each time is 1 minus 1 over n, right? To be not picked, that means 9 out of 10 in this case, we're not going to be picked. But you pick it 10 times, right? Then you need to raise the power by 10, right? And that's the possibility you never got picked in this round, in the back. And then use 1 minus this. That's the possibility to be selected, right? So if you let n go to infinity, you know this is 1 over e, right? That's the depth. If you put this in plus, it's e, right? That's 1 over e. 1 over e is 0.3 something. And then you have 65% of chance to be picked each time. But that's not too big. You always have like 30-some% that's not picked. Make sense? So it's not going to be the same bag. That's the point. Especially when n is big. You never could be the same bag. So now you start to run, and then you do the test. That's pretty easy, but it turned out this simple idea works pretty well in most of the time as a baseline algorithm. Very simple to do. You just learn to pick it and then put it to it. It is not the best, but if you compare the simplicity, that works pretty well. And random forest is another way to do it, particularly do the tree, the decision tree. And this focus is for the data with a lot of attributes. What looks like look the example of turned in. When you need to identify a document, you attribute all those special words, the keywords. Your keywords could be by much as 500 words if you look big documents. Since you have 500 big words, those words, and each time you might pick 10, you still have 50 different ways to pick it up, right? The random forest means you're going to build the shallow tree because you pick just a few attributes each time, and then you're going to let it vote. And in this way, because you mutually exclude these attributes, each are good in something. That sounds like a republic, right? We got a representative for each state, for each minority group, for each of kind of domain. Are you with me? Like that's how Obama chose his cabinet. You get a kind of a representative, and then the collective wisdom is bigger than the single one. And that's another one. Stack. Stack have a very good idea, but in reality, it's complicated. Simple idea. You got a classify, and this classify will be the output from this classify will fit as the input of the major classifier. This is just stack. This is level 0, that's level 1. And you maybe let the majority vote and even correct the original training example. And this idea really works pretty well for so-called unsupervised training classification and the semi-supervised training. In the natural language processing, the most cost thing is annotate. You need to annotate a lot of keywords, and it's very labor consuming, very time consuming. So the semi-supervised training is this way. They do this without supervision. That means no training, just do the what we're going to call clusterization. Just classify it. Clusterization is no training. You just see who associated with who is close to each other. And then you are intervene here. Once they get the result, you're going to check if it's good or bad. If the bad example go too far away, you just neglect it. If it's good, you take Then maybe the human being in here only take 20% of the work. 80% of the work you trust this. And that's another idea, sounds like the mechanical Turk. And then you can get the classify better. Basically, you don't get all the training cases human did, but the machine helped in the front. Human did that. That's a lot of like Amazon. In the same way, they have the machine crawling, texting, indexing, doing a lot of work, but behind the scene there's a human. That's why it's called the mechanical Turk. They're doing the decision and take the training, not take the training, and have a final check.